இந்த வீடியோவில் என்ன பார்க்க போகிறோம்னா, லாஸ்ட் வீடியோவில் நியூட்டன்ஸ் ஃபர்ஸ்ட் லா பார்த்தோம். ஆல்ரெடி வி டிஸ்கஸ் த நியூட்டன்ஸ் ஃபர்ஸ்ட் லா ஆஃப் இனர்ஷியா. அது லா ஆஃப் இனர்ஷியா கான்செப்ட் ஆஃப் ஃபோர்ஸ் இஸ் த நியூட்டன்ஸ் ஃபர்ஸ்ட் லா. ஸோ நியூட்டன்ஸ் ஃபர்ஸ்ட் லா ஸ்பெஷல் நேம் வந்து லா ஆஃப் இனர்ஷியா ஆர் கான்செப்ட் ஆஃப் ஃபோர்ஸ். In this clip, we have discussed the Newton's second law. So Newton's second law, what's the use? It represents the magnitude of force. How much of force is applied? How much of mass given? How much of acceleration produced? So it just represents the magnitude of force, mass, acceleration. So that is the Newton's second law. That is the Newton's second law. Just we go to the clip. For example, if you take, two objects, globe, for example, one globe, you rotate 10 units, you apply, acceleration is water. 20 units you apply, acceleration is water. 10 units means slow, move slowly. 20 minutes means move fastly. So acceleration is more for 20 units, acceleration is less for 10 units. So what it indicates? The force is directly proportional to acceleration. Acceleration depends upon force. Acceleration depends upon force. So if mass is constant, acceleration directly proportional to force. If mass is constant, acceleration directly proportional to force. One more factor depends, mass. Mass constant means acceleration directly proportional to force. Suppose here mass different, 5 kg, 3 kg. For both the masses you have to apply the same force, 10 units, 10 units. What's the acceleration? If you just pull this, 3 kg move fast, 5 kg move slowly. So lesser mass produce more acceleration, more mass produce lesser acceleration. Lesser mass produce more acceleration, more mass produce lesser acceleration. So acceleration inversely proportional to mass. Acceleration inversely proportional to mass. So from this we came to the conclusion by combining all the three effects: force, mass, acceleration. According to Newton's second law, acceleration equal to force by mass. Acceleration equal to force by mass. Acceleration is directly proportional to net force, inversely proportional to mass. If force increases, acceleration increases. If mass increases, acceleration decreases. So A equal to F by M, F equal to ma. So F equal to ma is the formula for Newton's second law. So Newton's second law give the formula for the force. Formula for force. Next unit. Unit of mass is kilogram. Unit of acceleration is meter per second squared. What's the unit of force? That is called kilogram times meter per second squared. The kilogram times meter per second squared is written as Newton. So 1 Newton equal to 1 kilogram into 1 meter per second squared. 1 Newton equal to 1 kilogram into 1 Newton per meter square. Next, the Newton's second law is also represented in terms of some other definition. What definition? The rate of change of momentum is directly proportional to unbalanced force in the direction of force. Suppose a horse riding is here. After a while, the horse just graze the grass. So some change in momentum takes place. Initial velocity u, final velocity v. So Newton's second law states that the rate of change of momentum is directly proportional to the unbalanced force, the direction of force. mv is the final momentum. mv is the initial momentum. Time t taken. So change in momentum mv minus mu. So rate of change of momentum means mv minus mu by t. Rate of change of means with respect to time. So mv minus mu is the change in momentum. With respect to time is t. So f proportional to mv minus mu by t is called rate of change of momentum. M common, m into v minus v t. V minus v t is the acceleration. So f proportional to ma. So this is the required one more definition for Newton's second law. Next, one more application is the Newton's second law. Why the cricket player lower their hands at the catching the ball? Here you just observe this animation. One cricket player just catch the ball in different manner. At the time of catching the ball, he just lower his hands. Why? Lower his hands because he want to reduce the impulse. He want to reduce the momentum. He want to reduce the momentum. He want to reduce the change in momentum. So only he just lower his hands. Otherwise, the injuries takes place in the hand. Voluntarily catch the ball, injuries takes place in the hand. So he lower his hands to reduce the change in momentum. He lower the hands to reduce the change in momentum or change in impulse. Then force decreases, time increases, then no injuries takes place. That's why he just lower his hands. Next, the same applications only. Newton's second law of motion. Why the cricket player lower their hands? Tell me. Because if the ball is catching voluntarily, injuries takes place. But if it just is lower hands, time increases, time increases, change in momentum decreases. Change in momentum is mv minus mu. That is m into v minus u. Decreases. Time increases. Denominator increases, numerator decreases means force decreases. If force decreases, momentum decreases, time increases, force decreases. Then automatically no injuries takes place. No injuries takes place. Force decreases means no injuries takes place. So only cricket player lower their hands at the time of catching the ball. This is the application of Newton's second law. This is the application of Newton's second law.